All right, in this lesson with our unit circle, we are actually going to work on operations with the trig ratios as we go around the unit circle. So we're going to need to be able to get a common denominator so that we can add or subtract our fractions. We don't necessarily have to sketch our angles or convert between radians and degrees, but we have those there as options in case we need to help us simplify our problems. So here we go. Quick little warm up. The first thing that we are asked to do is actually to add, subtract, and multiply a couple of fractions. So remember, anytime we are adding fractions, we want to have a common denominator. So 1/2 plus 3/5 will have the least common denominator of 10. So that first fraction gets multiplied by 5 to give us 5 over 10. Second fraction would be multiplied by 2 to give us 6 over 10. And when we add them, we will get 11 over 10. There we go. All right, another little shortcut that I learned way back in middle school. If we're adding or subtracting fractions, you can multiply the denominators together. So we have 4/7 minus 2/5, and I'm multiplying my denominators of 7 and 5 to give me 35. And then you can cross multiply the numerators and denominators. So 4 multiplied by 5 is 20. I'll tuck that up top. And 7 multiplied by 2 is 14. And then I'm going to subtract those two values. 20 minus 14 gives me 6. So 4/7 minus 2/5 hopefully should simplify to give us 6/35. In that case, if you go that shortcut route, you do always want to double check to make sure that things simplify as far as you can. All right, in 3, we're taking 2/15 and multiplying by 5/7. I always like to try to reduce either within the same fraction or crisscross applesauce, numerator and denominator. So 5 and 15 are both divisible by 5. That would leave us with the fraction 2/3 multiplied by 1/7 to give us 2 over 21. There we go. And then in number 4, 15 over 22 multiplied by 20 over 35. I'm going to go ahead and take care of the 20 and the 22 first by dividing them both by 2. And then I still have the option. I can simplify 10 over 35 in the back fraction, or I can simplify 15 and 35 going crisscross, which I'm going to do. 15 divided by 5 is 3, and 35 divided by 5 is 7. So now I have 3/11 multiplied by 10/7 to give us 30 over 77. There you go. Now, the reason we go through all of this is because when we're adding, subtracting, and multiplying our values around the unit circle, we're going to be dealing with a lot of fractions. So here's our first example. Sine of 3 pi over 4 plus cosine of pi over 6. Remember, sine is the y value and cosine is the x value. So what is the y coordinate at 3 pi over 4? That would give me the square root of 2 over 2, plus what is the x coordinate at pi over 6? That would give me square root of 3 over 2. In this case, both of my fractions have the same denominator, so I can add the two numerators together and put them over that common denominator to give me the square root of 2 plus the square root of 3 all over 2. You cannot add those two radicals together because they have different radicands, numbers under the house, and they're in simplified form already. All right, number 6, 4 multiplied by tangent of pi over 3 minus 2 multiplied by cosecant of 7 pi over 6. So I need to find the ratio y over x for tangent of pi over 3, which will give us just the square root of 3, and then I need to multiply that by a 4. Minus 2 multiplied by cosecant of 7 pi over 6. Remember, cosecant is the reciprocal of sine. So sine of 7 pi over 6 is negative 1/2. Therefore, cosecant is going to be its reciprocal, which would be negative 2 over 1, or just negative 2. And now I can multiply. 4 multiplied by square root of 3 is just 4 square root 3. And in negative 2 multiplied by negative 2 is a positive 4. So I have 4 square root 3 plus 4. Now if you want to be fancy, you could factor out the 4 and have 4 multiplied by the quantity of the square root of 3 plus 1, but that's not truly necessary. I like the first example, first answer best. Okay, in number 7, our two expressions are actually multiplied because there's no addition or subtraction between them. So I have sine of 3 pi over 4. So we saw that one earlier. That is the square root of 2 over 2 multiplied by cosine the x-coordinate at 7 pi over 6, which is negative square root 3 over 2. In this case, we're going to multiply the numerators straight across and denominators straight across. Because they're both a square root, I can multiply 2 and 3. And there's a negative out front of the square root of 3, so that'll give us a negative of the square root of 6. And multiply your denominators, 2 times 2 is 4. That will not simplify any further. You are all done. All right, number 8. 6 multiplied by cosine of pi over 6 minus 2 multiplied by cotangent of 5 pi over 3. So I need the x-coordinate at pi over 6, which is the square root of 3 over 2, and that's going to get multiplied by 6, minus 2 multiplied by cotangent of 5 pi over 3. So that's my ratio of x over y at 5 pi over 3. Which will be negative, so that would be a negative 1/2 over a positive root 3 over 2, and that will give us a negative square root 3 over 3 after simplifying and rationalizing. Okay, so now that we have each of those evaluated, let's go through and multiply and simplify. 6 multiplied by square root 3 over 2, that's like a 6 over 1. And you can write it as 6 root 3 over 2, or you could just go ahead and reduce that to be the square root of 3 over, just the square root of 3 over 1. You don't have to put the baby 1 there, okay? And then our next one, a negative 2 multiplied by negative root 3 over 3 will give us a positive 2 square root 3 over 3. That one does not simplify. So I'll just leave that as plus 2 root 3 over 3. Okay, now this answer is perfectly fine. The square root of 3 plus 2 square root 3 over 3. What we can do, though, to make it one fraction is we can change that first term, the square root of 3, to be the square root of 3 over 1. And then I can rewrite it as 3 square root 3 over 3 so that it will have a common denominator with the other term, 2 square root 3 over 3, and now that they have the same denominator, I can add the two expressions together. 3 square root 3 plus 2 square root 3. They have the same radicand, same radical, square root of 3, so I can just add the coefficients. So 5 square root 3 over 3. Either of those two answers are acceptable. Okay, we have a few others to go through and practice. We have cosecant of pi over 4 plus sine of 240 degrees minus 5 multiplied by sine of 13 pi over 6. Okay, I first see that I'm going to need a coterminal angle for 13 pi over 6. That's over 2 pi. So if I take 13 pi over 6 and subtract 2 pi, that would be the same thing as 12 pi over 6. I'll just get pi over 6. Therefore, I can rewrite my problem cosecant of pi over 4 plus sine of 240 minus 5 multiplied by sine of pi over 6. Cool. Now I've got everything in one rotation around the unit circle. Easy peasy for me. Cosecant is the reciprocal of y. So sine at pi over 4 is root 2 over 2. Its reciprocal is the square root of 2. Sine of 240 is just the y-coordinate at 240 degrees, which is actually going to give me a negative value. So it's plus a negative. You could just write minus if you so choose. And at 240 degrees, our y value is negative root 3 over 2. And then minus 5 multiplied by sine of pi over 6. The y value at pi over 6 is just 1/2. So I have the square root of 2 minus the square root of 3 over 2 minus 5/2. Okay, again, this answer is perfectly fine. Don't forget, we could take that first term, the square root of 2, which would be square root of 2 over 1, and multiply through 2 over 2. So I can write it as one big fraction, which would give me 2 square root 2 minus the square root of 3 minus 5 all over 2. There you go. All right, and our next one in this set, 5 multiplied by secant of 5 pi over 4, ooh, that's going to be the reciprocal of x, minus 6 multiplied by cotangent of 7 pi over 4, plus cosine of 3 pi over 2. Okay, so 5 multiplied by secant of pi over 4, so 5 pi over 4. 5 pi over 4 is the square root negative square root 2 over 2. Therefore, secant will just be negative square root of 2. Minus 6 multiplied by cotangent of 7 pi over 4 is going to be negative 1. And then plus cosine of 3 pi over 2. My x value at 3 pi over 2 is 0. Awesome. So I have 5 multiplied by negative root 2. That's just negative 5 square root 2. And then negative 6 multiplied by negative 1 is just plus 6. So negative 5 root 2 plus 6. Okay, and our last few examples that we have, we're getting there. Cosecant of 930 degrees multiplied by tangent of 0. Okay, the first thing I want to do is figure out what is tangent of 0. So what's the y over the x at 0? So that would be 0 over 1, which is just 0. Okay, so no matter what cosecant of 930 degrees is, I'm just going to be multiplying that by 0. So we really don't have to figure that one out. The answer will just be 0. Let's go ahead and do it anyways. So find a coterminal. 930 is way over 360. So I'm going to subtract 360 degrees, and that will give me 570. I'm still over 360. Subtract again. Find another coterminal, give me 210. So I really want to know what's cosecant of 210 degrees. Okay, well, sine of 210 is negative 1/2. So cosecant is going to be its reciprocal, which would be negative 2. So negative 2 multiplied by 0 does in fact give us 0. Yay us! All right, and number 12, sine of 150 degrees, just my y coordinate there, multiplied by cotangent of 300 degrees, the x over the y. Sine of 150 is positive 1/2. Multiplied by cotangent of 300. So my x coordinate is going to be 1/2. The y is negative root 3 over 2. So it will give me a negative square root 3 over 3. And when I multiply, remember, just go straight across, numerator to numerator, denominator to denominator. So that will give me a negative square root of 3 over 6. And you cannot simplify, so you're all done. Great job. All right, last two, secant of 200 multiplied by cosine of 585. All right, I definitely need a coterminal for that 585. So 585 minus 360 is 225. So I want secant of 210 multiplied by cosine of 225. Remember, secant is the reciprocal of x. So cosine of 210 is negative root 3 over 2. Its reciprocal will be negative 2 square root 3 over 3. And then multiplied by cosine of 225, that's negative square root of 2 over 2. So when I multiply those two together, I'll get a negative times a negative, so that's positive. 2. The square root of 3 multiplied by the square root of 2 is the square root of 6. And then all over 3 times 2, which is 6. And that does simplify to give me the square root of 6 over 3. And last but not least, cosine of 0 degrees is 1, multiplied by cosine of 180 degrees is negative 1. 1 times negative 1, negative 1. Great job. All right, that is the end of this lesson. Make sure that you practice some stuff on worksheet H. Have a great day.